Hi, it's sparxUK here again. Next on the bench here, I think, is the Spitfire. I want to say, yeah, there we go, Spitfire 500. So I'll post a link to the GitHub page and talk a little bit about that in a minute, perhaps show you that. It looks like it supports a couple of, I want to say flash ROMs, maybe RAM actually, RAM chips. Yeah, those are going to be RAM. It's got a CPLD, obviously goes into the CPU socket. And it's offset, isn't it? So you can put your CPU on the top, or some of the CPU maybe a faster one, I'm not sure. I know nothing about this. We've got a pin header here for the IDE, so it's got an IDE interface, look. Two more chip positions here, I'm guessing for RAM again. And what looks like a PLCC footprint there, which I suspect is going to be a ROM. So that's very cool. This came from Barry, sparxUK. Who else would it be from? He sends everything. He's such an amazing guy. He really is. He's my distribution centre here. This is sealed. So it says here, Spitfire 500, open carefully. One small part easily lost. So thank you ever so much for that, Barry. He also sent these, I think, which may have originally come from Live 2 or someone. I don't know. Or maybe Barry had these printed as well, manufactured. So they are 8372A. Hang on, 8372A? Oh yeah, this is so you can fit an 8372A in place of an 8375. So you can use the 1 meg Agnes and fit it that way. There's also space for the RAM here, 256 by 16 DRAM, one on each side to give you 512K, I think. So that's curious, isn't it? And it says they're Diet Agnes, so I think this is a Live 2 project, isn't it? Yeah, it is. github.com/live2. So we'll have a go at building one of those in another video. I'm just not sure how that works, really, in the sense that an board that needs an 8375, it's going to have a mega RAM, so why do you need this RAM? Maybe you don't need the RAM on the motherboard and you can just have this RAM. I don't know. 256 by 16 though, two of those is going to give you 512K, so not a meg, or not 2 meg, and you can't have 2 meg with an 8372A anyway, unless you were to have half of it as chip RAM and half of it as slow or fast RAM. So anyway, we'll look at that in another video. There's some bits here that I think are some 288 CPLDs. We've got a PCB there that I think I've shown before for testing and programming CPLDs. That's under the Matthias Heinrichs project, I think, so we'll cover that in another video. And some stuff with the TK2, so those are all just things that have slipped in with it. So I think, as far as I understand, it's just that box, and hopefully we'll have most of the parts we need there. Yeah, so let's open this little package together. I'll just get the wrist strap on here, just to take away any ESD, static electricity, that may be on me, because I've got a jumper on, and you can generate static electricity even if you haven't got a woolly jumper on. You may think you're immune to holding static charge, and you're not. Every movement you generate static electricity. Wow, that is well stuck in there. There we go. It's just, why is that open? So you did say open carefully, so let's see what we can lose here. Wow, that's stuck down. Yeah, that there could be lost really easily. Look at it. I don't know what it is. A tiny regulator or something, probably, or a transistor, even logic. So we've got the 4 RAM ICs here. You've got to be careful with this stuff because the pins can stick into the foam. There we go. 1, 2, 3, 4. 4 RAMs. A ROM. It is a ROM, it's a flash ROM, that. The part number is 39SF010A, so that's 128K. Same sort of family as the 27C010, but in, EEPROM flavour. With the 39 prefix there, it's an SST part of that. The RAM is Cypress, I think. It's a CY62167ELL-45. 45 nanoseconds, that's pretty fast, that. So I'm assuming SRAM. The pins on this one here look a little bit bent, maybe. Or maybe not, maybe it's just, I know they are a bit bent on the corners. And that's one of the things, when in these foam like this, they do tend to get a little bit bent. And then maybe this is a CPLD, so this is Xilinx. And yeah, that's a Xilinx, and it's an XC95144XL. So that's quite cool, isn't it? I think we've got everything. Oh, I've got another flash ROM here. Why have we got another flash ROM? maybe he thought he'd not sent me a flash ROM, or maybe I've got an extra flash ROM for something else, because I know, yeah, there was a point where I did need one for something else, so it may well be this flash ROM here was sent for another project, like the TK2 for example. And I don't have any of those spare, so that is a really good thing to have for one of the TK2s. I've got 2 TK2s coming up, builds of those. I've also got the RTG card that you've not seen yet. That is coming up, 2 of those as well, which I really thoroughly enjoyed building those. That was a birthday gift from Sparx, and I think some of the people on the Discord as well, it wasn't just Sparx, or maybe it was just Sparx, because I had a lot of stuff that year. They sent me some incredible things, and it's like I haven't got over them, how amazing they were. So yeah, this is the IDE adapter, and it's a 90-degree one here, which is perhaps what you want with the Spitfire, because if you're going to fit this in a 500 case, look, polystyrene's come out the end there, it's all stuck on the tape. Space is a premium in a 500, isn't it? So you don't want your IDE pointing upwards, otherwise you'd need, you know, I don't know, a cable that goes outwards or something. If you've got a 90-degree connector like this, where the pins are facing outwards here, well, it means you can have your compact flash adapter somewhere in your case, and it's hopefully not going to get stuck on anything. So we've got some tape on here. Let's just try and peel this off if I can. There we go. I'll clean this with IPA before starting. Whenever you have sellotape on a board like this, do wipe with IPA. You can see, you know, there's some mucky marks and things on that, and we'll get a really bad solder point if we're not careful. And there's nothing wrong with shipping it that way. That's what you should do. My point is, there's just things you need to do before you start to solder. Make sure your PCB is nice and clean. So there's our nice 90-degree connector. I've never seen one like that. I've never seen one like that. Yeah, hopefully it's focusing okay. So yeah, that's going to go on there. I'll stick that on last, but that is where that goes, like that. Now there's another one of these Spitfires, came from the original creator of the Spitfire. Liv to add an involvement in that. I'm not sure whether Liv ordered the parts, whether he funded some of the cost of the parts. I need to check, but that'll be another video. And it's the 2000 version of this, so this one's for the 500. But there is one that's designed to go straight into a 2000. So I'm super excited to look at that, and as I say, all the parts came with that as well. So these are just 2 amazing donations here, one from Barry and one from the original author and Liv 2. Yeah, so that little IC goes there. I'm going to need a voltage regulator, and I've not got one here. Hopefully it's the standard pin out there, because I've got quite a few of those, and if it's not, I'll bodge something on. And well, we've got a lot of positions for caps and things here, so that's the next port of call here. I need to go, and maybe resistors, I need to go and have a look at the bill of materials for this and see if I can work out what parts I need to fill all these gaps. The capacitors are going to be easy, because, you know, it's that suck it and see thing again, you know. I talk about it all the time with capacitors. Lots of them, 100 nanofarad caps are going to be fine. Yeah, most of the ones that go on the chips here, you can put 100 nanofarad, 100 nanofarad, 100 nanofarad, you're not going to have an issue. And there may be 1 or 2 that just need to be specific sizes, but I suspect 100 nanofarad all across the board, and then around the regulator here, like a, I don't know, a 10 and a 22, or a 10 and a 47, or a 1 and a 22, something like that. But there are some resistors. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, there's like 12 or 13 resistors on this at least. So that's going to be a problem. Yeah, that little IC, that tiny little one, it goes down here. There's the footprint for that. Which means, or is it that one? Hang on, I'm getting confused here now. Where's that tiny one gone? Have I lost it? No, it's here. Yeah, that's going to go down here. I can't even put it on the board, it's so small. Yeah, that's going to go down here. It's the right footprint for that. Which means, I don't know what goes there. I don't know. So, I am a few parts missing here, aren't I? That RAM chip has sneaked its way down into the packaging there, look. I need to get that out before it squishes itself. Let's just try and put it up here. Yeah, so there's no other parts there, I don't think, so I've not lost anything. I think that was the one that he said I could lose. Now, Barry may have provided the other parts with something else, so I do need to go and check to see if I'm if we've got the parts elsewhere, because he sent stuff with the TK2 as well, and there's loads of stuff with that. And it's designed by J.Bilander. There we go, it's confirmed. It's not J.Bilander, as I said in a previous video. It's J.Bilander. So, very cool. Copyright 2021. Yeah, I haven't got any resistors and caps, so I'm going to need to raid my spares and order anything up. I'm thinking I may get a PLCC socket on for that flash ROM, rather than just solder it straight on. It may add a bit, well, it will add a bit of height though, so I don't know. I might not be able to do that. But you see, I'm not sure, do I need to flash that in advance? Can I flash it while it's in place? So I need to go and look at the GitHub page now. Right, so I printed off the bill of materials here. I'm going to start with the 10 microfarad caps here. So some of the SMD ones are 10s. There's loads of 100 nanofarad, as I said. So yeah, that was a bit off. Good luck. We'll rotate that way. And yeah, C1 and C2, the first ones here. So I'll use this partially empty strip here. There's like 3 left on this one, I think. But I do have some more, so yeah, so let's just lob 2 of those down there, I think. Yeah, still got 1 in there, look. Oh, I know we've got 3 on the board. Yeah, C2 is there. So let's just shift that one out of the way. Let's just get a tiny bit of solder there. Smoosh that into position. Like so. That's not too bad, is it? Oh, hang on. It's not too bad, but it's not in position. I actually touched it and it just flew off. Now I've got some tweezers from Commodore. Let's just see if we can give those a go, if we can find them. Yeah, so I've got them here. Amazing, thanks for those. Let's just see how much easier it is with some tweezers. And they did say don't press very hard, and you don't need to, but otherwise you'll bend them. Hang on. I'm still finding it pretty hard, even with tweezers, if I'm honest. Just because, well, hang on. You can still see it moves around even though I was holding it in place. Yeah, anyway, it's going to be easier using tweezers. So I expect the tweezers, the cav tweezers, to appear a lot more moving forward. Yeah, that's that one. C1 was the other one, wasn't it? Where is that gone now? I've lost it. Yeah. So C1 is that one. So we'll do the same thing. We'll just get a little bit of solder onto that pad there. Just rotate it around a little bit and use cav tweezers to carefully position and align that. See, like it's flowing upwards. There we go. And I guess that's the problem with using microscope. It makes you more of a perfection seeker than it was before you had a microscope. I had pretty bad OCD when it came to these things before getting the microscope. So let's just check what C3 is. Yeah, C3 is a 0.1. See if there's any more 10s. Yeah, C13 and C14 are 10s as well. So let me try and find those. So we'll do the same thing, just get a wee bit of solder there. Rotate around a bit. Bring in cav tweezers. Yeah, when you're buying these capacitors and resistors and stuff, buy yourself a pack of 50 or 100. You won't regret it if you're doing lots of builds like me, because, well, we've got all these spares from some previous project, probably the CF1260, I think. And I suspect that's where a lot of these came from. Because I would have bought packs of 50 or 100, certainly 50. Let's try and squeeze that in. It's a bit bigger, this one, isn't it, I think? Or is it? Don't know, it feels like it's... No, it's not, it's the same size. It's a different manufacturer though. You can see it's grey and it's not the same colour as the other ones. Oh, God. Oh. See, it's floating up again. I don't know, I've got mixed feelings about using tweezers, because they don't have this issue where it floats usually. If I'm using something else, it sits flat. So quite why the tweezers are making it float. You see it's floated up again here. That'll do. Yep. Anyway, that's the 10s. I'll get some of the 100s on, but I'm not going to show you because I've just covered it all to death really. It's the same for all of these. I'm going to use the tweezers, the magnifier, the microscope, cav tweezers, cav cam to do each one of these. I'll report back when the caps are all on. Yeah, so for the smaller components like this, I am finding it easier just to use the solder. It's what I'm used to, I guess. The tweezers, though, are really good for slightly larger size components, I'm finding. So anyway, got those little strip done there. Still got loads of resistors to go and check to see whether I've got spares for, components available. I think that's most of the caps, actually. Yeah, there's a couple more. There's one here that I missed, C6. And there's one here by the chip there, C15. So I'll just get those ones on. 100 nanofarad again, these are all 100 nanofarad. It's just those 4 10s that we did at the start, and then all the others are 100. So pretty easy in terms of, well, for me, because I've got all the right parts here. Right, that's all the capacitors done with, so I can put those away. Yeah, so I have got some 10k resistors here. They're bigger, aren't they? I don't know actually. They're right for the pads, so you know what, I'm just going to go with them. Yeah, cleaning up each one of those as I go along, but we'll sort it when we're done. Another observation is when you fit in some of these things, maybe fit the chips before the caps. It could be a little bit tight clearance there, but I'll be alright. I like a challenge anyway. Nothing is impossible. Yeah, so those 3 there are mounted with hot air. They're exactly the same size as the pads, but they're pretty straight, 4K7s. They're optional, optional size. You can either have 4K7s or 10K, so I could have put the 10Ks on, which would have fit perfectly. And yeah, I just got the solder underneath and used the hot air, pressed it down. There was quite a lot of extra solder there. I just used the desolder braid and just reflowed them from the side. So they did look a bit blobby there, but yeah, they're going to be fine. Right, so the following day, I'm in absolute agony today with my arm. I don't know, I pulled something in my back the day before and had problems with this arm, and yeah, just in real pain with it. I'm going to use one of these I just dropped one on the floor. Let's use that one if I can find it. Yeah, these are regulators that at some point I have tested on something or wired the wrong way and it got warm, and I just took it off and swapped it. So I'm taking a chance here. But, well, we can try and feed, and I'll do that next actually. Before I fit the chips, we'll get this regulator on. I'll solder on a wire or something and connect up the bench power supply. Just make sure it's output 3.3. It's just a good way of using these, because like I say, there's a number. I've got 5 or 6 where there's a couple actually unused, but there's like 5 or so there that we're just floating around with bits of solder inside my components tray. I just like to try and, well, you know me, I like to try and be efficient. I mean, I have got a big strip of those AMS 1117s there. That's why they were super cheap. Now they're not. When I got those, they were, I don't know, it was like £2 or something for like 50 or something. Now they're not. Now it's like £2 gets you 1 or 2 or something. Maybe 5 if you're lucky. I'm just checking that, AMS 1117 3.3. You do need to check, because some of these regulators, the same part number, has multiple subversions. So an AMS 1117, you can get a 1.8 version of that. I'm sure you can, because, well, I ordered one recently for something else you may see on my channel. Yeah, what's the saying? Waste not, want not. So, like, if I was to not attempt to use these now and work out if they are good, well, they'll end up in the bin, won't they? And at some point, those regulators will run out, the ones I've got in the bandolier there. Having said that, I don't think I'll be here by the time they run out. Right, anyway, let's just get a bit of solder there. Yeah, I think the legs on this have been bent or something in the past, because I'm not sure that's fitting as flat as it should do. Let me use the tweezers here. Yeah, so so the tweezers need widening slightly, just so that I can, here we go, get onto it. The nice thing is I don't need to do much, just align it now. Stuck, there we go. Yeah, it's not quite as straight as I wanted it. It's still not quite straight, is it? We just push it down here marginally. Now it still feels like it's not right. Oh, I don't know if that'll do. It's pretty blooming straight. But I think these legs were bent up at some point. I think I bodged this on something previously. I could be wrong. I mean, that pin looks nice and straight. But even the tab doesn't feel like it's really fitting flat on the board there, but it's going to join thermally with the solder. Well, there we go. Once it joins the PCB there. So I'm just going to get a tiny bit of flux on those points at the bottom. They all look awful. Right, the bench power supply is set to 5 volts. It's not actually on at the moment. I've got a little pin header just plugged into there, 5 volts and ground. Hang on. I need to do something underneath that really, or that's just going to get pushed down. And we'll connect up the ground first, and then the 5 volts, which is off at the moment. I'm just going to route these wires to the cable relief over there, and then look, they don't get pulled. You can just sit on the bench like that. And if we just position this accordingly, and I'm just going to switch it on. I've limited it to 400 milliamps, drawing 0.034 amps. That tells me it's working, because, well, when they're not, they don't do that. You get much more current draw. Just checking the thing here. So I think the tab is 3.3, and then the ground is the first pin, isn't it? Yeah, it's not that one, it's that first one over there. There we go, 3.3 volts. So that regulator is good. Right, so I guess the next thing to do is get the RAM and CPLDs on. So I'll get the strap back on again. Yeah, I'm looking at the GitLab or GitHub repository there, I forget which it is. You can see the chip like that. So I think as we're looking at it now, the writing wants to be at that angle, you know, sort of left to right. I'll show you what I mean. Yeah, back on here, it wants to say Xilinx down that way. So if I just get the tweezers to help me do this thing, and let's just put it in position there. I can't see the writing on that now. It's like, oh, what's going on here? Where's Xilinx on that? I don't know. It's like, I don't know what's going on here. It's the first time I've ever seen one of these where I can't actually read anything on it. Right, that's not right. It needs to go all the way around that way, doesn't it? I think. That is surprisingly dirty, isn't it? I don't understand how it's got like that. I mean, it looks like it's never been used, but why is the top of it weird? I need to adjust the focus as well somewhat. Let's try adjusting the light in here. Yeah, that's not helping. I think I need to get a tiny bit of IPM to a cotton bud and just wipe the top of that. It's not filling me full of confidence. This is like an eBay China or AliExpress special. Maybe it's already been programmed up, this. Maybe it has been on the board. You see, I've just wiped that with some IPA, and oh, there we go. It's coming back now. See that, Xilinx? I think that's a bit of flux, actually. Yeah, anyway, that is the right way around. So just look at the top of the board there. There's the edge. You can see Xilinx down this way. And I actually don't think I can do it that way. I think I need to switch from Kavanagh's cam to parent cam. Just because with this, you see, I can just see a lot clearer when it comes to lining the pins on this. Just solder one pin of each, and then I can go back to using the microscope. Yeah, there we go. So I've just got it aligned. I haven't anchored anything. It's just far easier when you're trying to align multiple sides at the same time to use something that's where you've got stereo vision. So I'm just going to try. Oh, hang on, I moved it. I hope I haven't. May have moved that. I don't know. I need to re-inspect. Yeah, I think that's all right because the pins here look good. So let's just anchor it up here somewhere. Yeah, and then coming back down here again. This just needs a micro adjust. So I need to just heat this and then pull down towards the left hand side of the camera here, just marginally. That'll do. And that works by moving it marginally that way. These are all still perfect here. They're all perfect up there, I think you can see. But these, hang on, they might still be a bit far. These were too far up on this side here, but now they're not, I don't think. Let's just look at it from that front. Yeah, still slightly to the left, can you see? But they're on the pads. So by moving it that way, it pulled this corner here down. Yeah, it pulled this edge this way, which just moved them all slightly further that way. I think that's alright. Wow, this RAM's going to be difficult to do. It's, well, we've only got two sides, so it makes it a bit easier than the CPLD. But, well, there's nothing to solder onto here. You need a soldering iron with the size of a pinhead on it. So this is going to move, isn't it? Just trying to solder that. Well, I don't know, it's not going to happen. Look, see? I don't know. It's going to be a bloody nightmare, this. I think what I'm going to do here is just get the solder onto that first pad or so, like that, and then try and manually smush it, there you go, into that solder, and move it right up there. So I think that's fairly straight on that side, but it's not. And then look, you see this side's now out. So what I tend to do with things like this is just ignore the fact that side's out and just do this side. So if I, it's just only one pin soldered. Look, if I just bend it, when I say bend it, I'm just moving it gently, I can align that perfectly. So let's do that down here. And inspect up there. See, those are all good now. And on this side here, we're going to have a bit of tension. If I can find it, where's it gone? I don't know where the chip is. It's gone, there it is. You see, that side's pretty good as well now. But what we can do is just press the chip, just refollow that pin, and then the tension will come out of that pin. That's it. Because we just, micro adjusted it while that was in the wrong place, really. And as long as you're not too far off, by degrees, then doing that, you won't have any issue. It's just far easier than trying to keep readjust it. So we're going to turn up here, I think, just get, I'll try and get, and of course dedicated flux would help that flow. And that's what we're going to do when we come to solder in a minute. What is going on here? That is not flowing. There we go. I just want it anchored in two places because those were not diagonal, and we'll do it up here as well, just so that it's anchored in four places. Again, should I have fitted this before all those SMD caps and resistors? Maybe. I think I'm going to be alright though. It's like there's so many things in the way here now. Should put my finger on there just to hold that as well. That'll do. And I didn't show, but the writing goes that way up like that with, you know, the chip there. And I guess there is a pin 1 thing I've just spotted here on these, so there is a clue. It's this here. See, the white silhouette overhangs more on that side, and this side here it doesn't, and the one down here it doesn't, and it doesn't. So there you go, that is the pin 1. So that's the first of those 2 RAM chips fitted on the other side. This is the chip that suffered a bit of an ouchie. See, the pins on that side are okay. When I say an ouchie, in its bag, in its you know, container there, the SD packaging, and I'm not even sure I can do it this way. What I was wanting to do is, there you go, press down, look, just pressing down, so it's just flat. All I'm doing is flattening it out, yeah, because they were folded under. The foam had just caught on the underside. If I just rotate this way, so you can see that's not bad actually. I don't really need to do very much here, other than just hold it down firmly. Use the cav tweezers here. I'm so grateful for these, because you know what, I haven't got anything this fine. And just do a little press, there we go, and a little press, just hang on, yeah, that's not bad actually. I think, I actually think, oh, I don't know, it's really hard to tell. Let's just get the focus a bit better. And I can use the digital zoom. Let's do that. Let's zoom right in on that. Yeah. It just, when you can get that close, it does help you work out. And actually, that I just micro adjusted this one a bit too far that way. That's it. So yeah, it is anchored on that side, and they're pretty straight there. So if we go down this side here, yeah, they're not quite straight on this side, I don't think. I don't know. It can be an optical illusion, but nevertheless, if we just try and do this one up here, up, and then what I can do is just press down and reflow it. But also press, I was going to say downwards, but when I say downwards, I mean down that direction. But actually, they're straight. They're pretty good look. So I'm going to do the same thing. These I've been anchoring on all 4 points here because, well, I just don't want them coming loose when I start to solder them. And I'm probably not going to solder them now. I'll do them later. Right now, I just want to get them anchored in place. Oh my God, look at the size of that. There we go. That'll do. So the last thing here before I solder those chips in entirety, you know, all I've done is anchor them all, is this wee little thing here, which goes, where is it? Up here. It's the one that Spark said open carefully because you'll lose it. Now, where's pin 1 on that? Well, I think the line, hang on, I think that line there means pin 1. And on the chip we've got 2 dots, we've got a dot there and a dot there, that's got to be pin 1, hasn't it? It's a little Schmidt this, a little Schmidt inverter or something. I don't know, I'm kind of thinking it's going to go, hang on, there's a dot there, what's that? Is that pin 1? Hang on, there's a 1 here, that's pin 1. I really wish people would just put an actual dot somewhere rather than these lines. So I think this being pin 1 here, that's got to be pin 1. Oh, hang on, I'm just trying to work out what it says on it. It's a 14, isn't it? There we go. Yeah, it's a Schmidt inverter. So it's 74 something 14, and that has got to be pin 1. But why is there a dot there? It's like they get a bit confusing, these things sometimes, don't they? Certainly when they're this small. I think I would have struggled to get this on here without the microscope, actually. I mean, I've done these same sort of size components previously when I've done the 536 builds and stuff, the terrible file ones, because Stephen uses this same sort of part, I think. You can see how hard that is to get that lined up. Look how big my finger is compared to that. Oh, I just moved it. I didn't even touch it. It was the wind from my finger just moved it out of the way. I don't know, I feel like I'm not going to get it much straighter than that, because every time I touch it with the smallest amount of pressure, I think we'll just do the same thing we did before. We'll try and anchor it with the huge iron here. Look at the size of the tip. Look at the size of the solder. Oh my god. It's just going to move that. There we go. See, I knew that was going to happen. It's like, and it's all very well saying use the tweezers, solder with the tweezers. It's, you can't do that. I'm trying to feed the solder at the same time. Hot air is what you want to do with something like that, really. I mean, you can see I've more or less smushed that into position fairly well there. Hang on, just trying. I actually get things more crooked using this microscope than I did when I used the magnifier, because this perspective is everything. The angle makes you think something's straight, and then you change the angle and no, it's not. Oh my god, why is the solder going that way? I really need to use the antex on this. Why is that point not flowing there? It looks like it's not joining the pad. And we've touched that cap now. I'm going to go to use the normal magnifier in a minute, I think, to get this right, and I'm going to use the antex to reflow these, because, well, they're just shockingly bad. Maybe I don't need to. I don't know, the shape of the tip is everything. When you've got a tip like this, you see you just get these little beads like that, and you don't want beads. Let's reflow that. Oh, it looks awful now. That leg there is just terrible. What is going on with that leg? Right, I'm going to go get the antex because I'm just hating the soldering on this. Right, the antex is probably almost heated up. Let's just see if we can correct some of this bodgery around here with a bigger tip, but it's the right shape. Yeah, angle is everything, and I just can't get the angle I want with the microscope. Let's just get solder off the tip and just give it another go. There we go. Same with that cap there. That cap there, I have introduced a big blob of solder, and I don't like big blobs of solder. So just going to eat there like that. Hang on. Sometimes you can pull the solder up the edge of the thing. So I'll just get it right down there. Just absorb some of that. That's it. That's what you want. And we've probably still got some flux there, maybe. Nope. Now I've got it on top of it, and I don't like it on top of it, so I'm going to do that. Hang on. That's it. That'll do there. What else have we got? We've got a blob here now that I don't like. It's just a result of reworking in an area right next to these things. It's almost surface mounted, that one. That'll do. It's on. Hang on. And then we got a big blob on the top of that bit there that I don't like. Still not gone completely, is it? What is going on here? And then we'll reflow that for good measure. Yeah, there's still quite a lot of solder there. Right, and then these three bodgy things here. The gap is tiny. yeah, changing the angle there, changing the angle of attack there. Let's just see if we can get the giant tip down there. Yeah, they're not too bad. It looks far worse than it is because of all the blooming flux. I'm just going to revisit that cap there again because it's, I don't know, it just looks really blobby. That's okay. Oh, yeah, the point is, if you've got OCD, and I'm not making light of OCD, OCD is a real thing. And it can destroy lives, actually. It's a big problem, OCD. But I have a level of OCD. Not as high as you might think, but when it comes to things like this, I just like trying to do a really clean, tidy job. And when things just look imperfect to me, it can cause me issues where I spend far too long going over something and going over something a number of times, and I'm like, why am I doing this? It's just ridiculous. You can't even see it. And the reality is, if I compare this build here now to some of my previous builds with a microscope and you zoomed in, you probably see slight imperfections like this on those, and it never bothered me at the time because I couldn't see this clearly, is the point. So yeah, it doesn't pay really to go over the top reworking an area. You just want the components to be cleanly mounted with no shorts, good solder points. It doesn't matter if, you know, like this here, that little IC is not as straight as it should be. But looking at it from above, you can't tell. I can't tell. It's only the microscope that can tell. Same with these. These are slightly skew in relation to that. But again, looking down at it with my normal eyes, although there's nothing normal about my eyes, yeah, it looks fine. I'm not sure if I bent one of those pins there, or two of them. These ones on the end here, they don't look straight to me. But it could be the flux distorting the light. Anyway, I'm just going to get some solder on the tip and just gently come in here and see what state those are in. Yeah, look, it was just a trickle of light. They looked really bent, didn't they? Yeah, so I've got some solder on the tip here, flux all up the side of it, and I'm just going to go across like this. Those don't look like they are flowing at all. Just getting rid of the solder from the tip, and I'm going to go back that way. Hang on, like that. Solder from the tip again, and go back that way again. As I get out here now, I'm just going to change to going a different way with the iron. I've still got three there that are joined. Sometimes you can move the flux in like this and bob in and out, and sometimes that will just allow you to separate these things. If not, bring in the braid and just try. That'll do. And one final pass along the bottom. God, they look terrible under the microscope. Yeah, but with the manual magnifier here, they look fine. That's the thing. You can just see how bad something is when you've got the microscope. I'll show you on macro in a minute, but that has reflowed way better than I did that side, just by virtue of the fact that I could see from the right angle. I think it's about angle, because you see the microscope is going straight down, and when you're going straight down, well, you can't really tell what's going on. When you're looking at an angle, you can actually see the solder flow up the pin and the pad and everything. It just changes everything. Yeah, I could probably rotate that camera on its stand, you know, slightly to get an angle. I don't know, that might be something I need to experiment with. Anyway, the microscope has its uses and is a godsend for lots of things. Alright, I'm going to have a clean of it now. Yeah, that was painful. It just took me about an hour to go over all those. Yeah, so I often talk about this part, but don't always show you. The bottom 2 pins here, 5 volts at the bottom, then ground. So this is where you can power this board in order to give the regulator its 5 volts, that it provides 3.3 volts for these ICs, and you need the 3.3 volts in order to program. So, yeah, I'm just going to solder on 2 wires just onto the ends here, just temporarily, because I want soldered, reliable, solid connections for 5 volts and ground. You could just, pogo, push them through, hold them in, bend the board at the right angle, tongue at the right angle, and hold everything and hope it works. But the thing is, if you lose your ground, or you lose the supply, you could get a latch-up type fault, where you kill some of the chips on here. Now, in the guide, the build guide for this on the wiki, it does suggest fit your regulator and your CPLD, and then just program that on its own. If you've got a problem with your 3.3 at that point, you won't kill your RAM, etc. But you know what I'm like, I build these in entirety, check everything, double check everything, then just program it up. So yeah, 5 volts is going to the VCC pin at the bottom, that's the red wire, and the ground is going to the ground. So I can connect my USB phone cable to my computer there, that'll power it, and then connect the JTAG up to the JTAG connections, wherever those are, can't see them now. Oh, they're up here. Yeah, so let's just check the order. TMS, TDI, TDO, TCK, ground, 3.3. That's the same order I think they are on the Terrible Fireboards and stuff, so yeah, we'll go. Yeah, so I was back over to the PC and have a go at using this. You saw me program up the ROM there, and I had no end of trouble with that ROM, those errors. I had to do what I usually do, which is to reseat the chip a few times, and the PLCC adapter still didn't work, and put it in the socket, close the thing, and slide the pins around in the socket, open, close, slide it again, and eventually, by about the 5th attempt, it worked. It programmed. So it's that dodgy adapter. I don't know, PLCC adapter needs replacing, I think. Right, so you saw me program that up. No issues at all. Very pleasantly surprised actually. But I did, inspect to make sure there are no shorts. And when I powered it, always finger test to make sure that it's getting warm before you start trying to get your programmer up and stuff. Anyway, we can remove these now. We'll just use a bit of braid to clean up the pads on that. And we need just the remaining things really. Yeah, so you'd probably need to solder this chip straight on, because it fits right in the middle of the footprint of where the sockets go on the motherboard. This goes into a 500, you've got a socket there, and it's going to be very close to the edges of that chip there. So that's the only thing I'm not keen about the layout of this. But the layout of this board is really good, it's really well optimised. The fact you've got these 4 RAM chips here with a CPLD in between, and it's just really good use of space. It's very reminiscent of a Terrible Fire design in how optimum it is, really. It's like you couldn't have got that any smaller than that, really. Maybe just a couple of millimeters if you'd really tried, but yeah, I think that's as optimal as you could get it, actually, looking at things. You can argue there's just a tiny bit of space here, but that's to accommodate these tracers here. So if you look straight down here, you can't see the pads. That's the thing. It's a bit like BGA. So that's the other way you could mount it, actually, is a bit like BGA. Get solder on all the things, put the chip on top, heat with hot air until it sinks itself down. Put some flux around it as well, obviously. But yeah, I'll tend to do it this way. Anchor one pin, check its alignment, and then come in again with the iron, touch the pin with lots of solder and flux. And anchor another pin. Right, let me just check that. Yeah, that one's anchored as well. You'll note that I doubled up the ROM. It's 128K. The ROM image, the combined one from the GitHub repository, was 64K. It's never a good idea to write 64K to 128K chip, because you never know, there could be some floating address line somewhere. And of course you could double that ROM in a tactical way. In other words, I did consider putting Live2's Ripple ROM with that. It's 128K the ROM on the Ripple, I think, although there might be a 64K version now. Nevertheless, you could do that. You could merge two ROMs together and then have a jumper on there. It's got a jumper on now, I think, to switch between the two halves of the 64K, so we might not need to do that. But it said combined. The ROM said combined. Well, that makes me think it's two 32K ROMs, but I thought you had to have 64K at a time. Check out the A4000 repair I did, the Can I Fix This 4000, I think it was part 2, where we got one of those PLC chips back on. I covered the point there about how to get those legs flowing really well. That was painful to solder on, and that capacitor there, don't fit that until you got that chip on, because I had to remove it, and yeah, it's just like really close. There's no way I could have got a socket there, I'm sure. It's a shame there's nowhere else to locate that where a socket could have been fitted, because those J-leg ones are just, I think, way easier when you can fit a socket. Just hope all the connections are good. See, the difficulty here, because I've got a black PCB, it's making it very hard to see. I'm getting like glossy, shiny reflections on the black. Yeah, so I just need to use some light and magnification here to look around the sides of that, but yeah, I think that's on. It's this side that looks really bad. Right, we're up to what I think is, quite frankly, the hardest part of this. These long pins like this, I forget what these are, you get these on AliExpress. I got a big bag full of them here. Liv2 first used these on one of his boards. It was the RAM board, or the ID board, I think he did. Anyway, the pins go through the holes and they sink right through and they protrude a fair distance here. I think I need to trim all these other pins off here, yeah, like trim them low once I've soldered them. And then this is the question, is those going to be long enough now to go into a dip socket? What happens with this chip here? Is it going to interfere? And the stubs here, if they're not cut short enough. This is what I don't like about these kind of designs. I'm not suggesting there's an easier way to get around it. There isn't. You're stuck with what you're stuck with when you're trying to achieve this. So, I don't know, I hate these pin things, because I'm going to feed each one through, probably stick them into a turn pin socket below or something, make sure they're all flat and flush, and then solder them. How can you solder them on the underside? You could solder from the top side maybe, and I think this is what I had to do before. Up. And you can argue maybe do this before you do the strips, I don't know. Let's just get one through there. Yeah, I could solder the top side here, like that. But you don't want to solder them until they're aligned with something below, e.g. a piece of pin strip or a socket. Socket's better, because then you can pin the corners or something in the centre points, get your socket on, and make sure it's going to be, yeah, everything's going to be straight from that point, and push each pin through and solder it individually. So I think that's what I'm going to do. I'm just not sure what to do with the strips that are there now. Like, should I maybe solder these and then trim the ends off? That's what I'm going to do, I think. Yeah, we'll do that. I'll do that next. So I'll solder all of these in place and then trim them all down. Right, that's those two strips there soldered. My confidence level is diminishing with every minute I work on this, just because it's getting more and more and more complex in terms of rework. So what I mean is, well, good luck trying to rework that ROM when you've got all of these pins and things around here like this. And similarly, good luck trying to rework that CPLD when it's right next to this pin strip here. So you've got to really check everything as you go along. And I'm making some assumptions here in terms of cutting these pins. I think we need to cut them, because, well, it's just going to make it a bit easier to get into a socket. Yeah, to be fair, it didn't take long to get those off anyway. Got a turn pin socket here. I'm going to start by just getting the one pin into the one hole carefully. Hang on. Yeah, no, the solder's gone around that, all the way around it. So that's alright. And we need to do the same thing over here, without putting it down. This is the thing, because you put it down, this pin's going to get pushed up. So, I don't know, there's probably lots of different ways you could approach this, and someone's bound to suggest something far easier. Have I just filled the hole there with solder? Yeah, I think I have. Oh God, this is another reason why I hate these pins. It's like, you know, you get a bit of solder on the top there, it goes in the pin, and then nothing's ever going to go in it. Yeah, there's lots of different ways of looking at this. That pin that I took out before, I went, oh, I'll throw that one away. It doesn't matter, because these ones here, it doesn't matter if you get solder on them. They're not used. It's only the ones there that are used. So, you know, you could do the opposite of what we're doing here. You could put the pins all through, then put a strip of turn pin header here to hold them all in place. Flip it over, or just solder them all on this side. Yeah, while you press down on the pin strip. You could do that. That would work. And I got into the zone with this. It's actually not that hard, although it has stressed me out. If I'm honest, I just hate these flipping single pins. You sort of lob the pin into the hole. If you're lucky, it goes straight in, and then you just press it into the socket below. And then I do two things here now. I find the first one, heat the actual pin and pad, introduce the solder, don't worry if it goes into the actual hole, and then come at the other side of the pin, there we go, and the solder is flowed all the way around it and under, and then just do the same for each one here, so. And then blow that one right. So then what I do is the final step here is to start from the first one, press it down, hang on, heat it first, reflow it, press it down, hold it, move to the next one holding the first one, and just keep repeating this as you go along, because you're pressing them nice and straight, and if the odd one like that one there sank down a little bit, the odd one is not as low as it should do, okay, that will sink us a little bit as well, it will sink in, as well as being super flipping straight and being reflowed. Right, that's it, my brain is frazzled, my neck and my arm are killing me. I have finished it. I did just solder with some flux down this side here as well, just to make sure that those pins are really, really well secured on the. Now, this is going to be the fun thing, isn't it? Trying to get this off. There we go, it's off. Yeah, so my turn pin socket is no worse for wear. And all of our pins are now nice and immaculately straight. Anyway, I'm going to clean around some cotton buds, an IPA, toothbrush and IPA, and then get it in the ultrasonic cleaner. Yeah, so I put it through the ultrasonic a bit prematurely. It's nice and clean, but we need to solder this on, and we've got some jumpers. That's all that's remaining. Well, and the missing PLL chip there that's on the way. But I was looking at this and I'm thinking, I really want one of those, you know, a female one that's at 90 degrees that comes out of there. And then it dawned on me, this is what it's for. Because if you take this cable off this, yeah, you can just plug that straight into that. So that I am going to solder that straight on. I'm going to go with that. I'll order one of these, another one of these for this, and an SD card. And we'll use it with an SD card rather than a compact flash, and rather than using the wider pitch stuff. Well, we can't use the wider pitch stuff, but rather than using a female, because that's what you'd expect there for a cable, yeah? At least the SD card thing's just going to go straight there. Now, the next issue there is, in a 500, is the clearance for the ROM. I'm not even sure. If you had one there, is that going to interfere with the ROM? It might do. Ta-da! Almost done. So, I put all the jumpers on there, I cleaned up all the solder points, fitted this, cleaned up the solder points again. So, it's looking really, really good. You may be able to see the odd smear, and the only thing we're missing is the PLL chip. So as soon as that arrives, we can test it. We've got jumpers in all the relevant places. I think I might have disabled auto root. I think when it's on, it's disabled. When it's on there, it might be in 4 meg rather than 8 meg. I'm not sure whether that's 7 or 14 megahertz, and you can switch it in real time, by the way. So if you know, to route a wire there to switch somewhere on your Amiga, a fly lead out the side, for example, you can switch it over without rebooting, and it just works. It toggles between the 7 and 7.09 and 14.28, is it, something like that? And then JP3, which is the Octagon Octopus, which I'm finding strange because the ROM said it was a combined ROM and it was 64K, but I thought these were 64K ROM, which means I think it's only going to have one ROM here. Even when I switched it over, I think it's just going to toggle between the lower and upper half of that 128K chip, and I've just got a copy of the same thing twice. But I could be wrong. It could have had a 32K ROM. I don't think so though. I think they need to be 64K, don't they? It's an NBN3502DG. Yeah, so going with the Rev 6A Amiga here that I fixed in a previous video. Oh, there you go, Kickstart 2, that's good. But it has got the solid core ROM adapter. It's quite a tower. And this is the thing, switched it off now. How would you fit this there when that's there? So, yeah, that is a problem, isn't it? I think what we'll do is we'll just take this out, and I'm going to put Kickstart 3.2. Yeah, so this 3.2 came from Stephen Leary, which was incredible. He bought me the kit here for Kickstart 3.2. Where's pin 1 on that? It's there, which on this one is pin 1 at the top, isn't it? I'm actually not sure what I was thinking of putting a certain pin socket there for the ROM. Woohoo, after a nice age, just trying to get that in, it works. So 3.2 ROM at the moment. Yeah, it just gives us a little bit more clearance. I'm going to also put another socket here, because I've got the round pins on that Spitfire. I do not want to damage the original dual wipe socket below. So, set the CPU out. I'm going to put another socket into that socket. So pin 1 here is this side, look. Yeah, so the CPU's gone in. Pin 1 to pin 1, etc. So let's try that. Yeah, getting a green screen, as you can see. Swapping the jumper over there for CPU speed, still a green screen. Right, I'm putting it straight in there with the intention of replacing that socket with a turn pin socket, because it's pretty worn, I think. And yeah, the pin 1s are aligned correctly. Let's switch it on again. See what happens this time. Yeah, so I don't know, after all that, it doesn't work. It doesn't work. Yeah, so I figure let's get diagram into it. I'm just going to give that a squish just for good measure as well. Pin 1 up the top here again. Right, so not working. Just give me a green screen with Kickstart, and then green and red flashes with diagram, which, well, it's not good. I need to get a bit closer, I think. Yeah, I'm thinking we've got, you know, a compromised bus somewhere, so those pins don't look so clever, do they? Just the alignment of them. They look more aligned to the right than the centre. Yeah, I don't know. Although those are aligned slightly to the sides, they look alright, I think. I'm just looking for bridges really at this stage, or a pin, you know, clearly not soldered, but they're looking alright. Well, on a hunch, I tried a 16 megahertz chip here, thinking, and it's a HC one, this, yeah, thinking, is there some sort of issue, does it maybe not work with a stock CPU? And I tried the jumper for the speed in both positions, but I also was toying the idea that maybe it's stuck on 14 megahertz, and it works, it boots with that. Well, so I'm kind of pleased, because we're getting past the red and black flashes, or red and green, and then everything here is coming up. So, I don't know, I'm really puzzled. I could have spent quite some time reflowing things there, and I did just reflow a couple of points around resistors, you know, the ones where I'd mounted them surface style, thinking, you know, was there a bad connection there, but that wasn't the issue. Right, let me connect the mouse up. Yeah, the memory, I'm not sure, well, I'm not sure anything's, well, it's not reporting anything, look. So if we do memory tests, isn't there a complete memory detection? And we've got 0. It says there, detect 8 meg. Yeah, there we go. So you've got to run auto detect, and then you've got to complete memory detection. And now we've got 8 meg down here, it's fast, so that's really good. So we'll test the fast mem. And fingers crossed. And toes. But that's not what I expected regards to this CPU. Like, what is wrong with this CPU? We know the CPU works on its own. Pin's nice and clean on it. So, very, very weird. The only thing I can think is it's like locked in 14 megahertz at the moment. Bear in mind I fitted a 16 megahertz HC part. So, yeah, it's 74. Yeah, it's an MC68HC000P16. Is that what it needs? I don't know. I didn't read anything on the wiki suggesting it needed a new CPU, but maybe it does. Anyway, I'll let that go around the full range. It's going to take some time, and I'll report back. Yeah, and whilst that's memory testing there, it's up to 3 meg at the moment. I did fit the jumper here, I took the one off there, so when that's off, it seems to be an 8 meg, and you do need the first 2 pins on this 5-pin thing over here, jumpered. I think it's the config in. I think it's just like disabling auto config effectively, so that this can just be an auto config device on its own, the RAM, that is. And the SCSI, probably. Yeah, so obviously I'm not really sure whether the SCSI jumpers are set right. And when I say SCSI, I mean IDE, but it's going to use SCSI.device, isn't it? I always found that interesting, that we use SCSI.device to boot hard disks, including IDE ones. IDE, well, it must be a form of SCSI, I don't know, or SCSI is a form of IDE. It really confuses me. I'm sure they have different protocols, so I don't know. Anyway, we'll try this next. It's got a 1200 card, so I don't think it's going to boot unless it's emulating Gale side of things, but I don't think it is it? It's not Gale IDE emulation, it's proper SCSI in terms of an auto config device. It's not going to be set at the Gale location, you know, the Gale address, so I don't think that'll work. I think I'm going to need some sort of other SD card setup. But you can see we've just literally approaching a 4 meg boundary. 4092 is it? 96, there we go. Yeah, my memory's fuzzy. Half of it is okay so far, but that's so slow. Yeah, whilst that's still memory testing, one thought I did just have is that maybe the reason this doesn't work is because whilst it's got this intelligent clock switching stuff going on, maybe when it starts up in the higher speed just for a number of cycles, and it's like messing something up. I don't know, like this can't run at that speed or something, I don't know. And of course it could just be that it's stuck at the moment due to a fault or something in the 14 megahertz mode. Ah, yeah, you missed that. It literally stayed on the screen for a minute and then went off. It passed to full 8 meg. So the RAM is all okay. I think the next thing we're going to do is just switch the scope on. And I want to scope the clock pin. Actually, just curious to see, like, now we've got this set to 2 to 3. Is it running at 14 megahertz? Oh, God. Yeah, what speed is this actually reporting? So let's I can remember where it is. It's somewhere up here. It's pin 15, I think, isn't it? Right, it's running at 14 megahertz. Is running at 14.1875 megahertz. So I'll switch that back. I'll perhaps do this while you're watching, and we'll press run stop again. We'll just see if it switches back properly. Is it that one? No, it's not that one. Yeah, I'm just like prodding around different pins here, just trying to guess where it was. There we are. So 14.18. Now the ground is really loosely connected here, so we may just lose the signal a little bit. It's not even connected now. Like, move the jumper over. Right, I'm going to put it in 1 to 2. Oh, that works. It's back down to 7.09. And the machine hasn't crashed, so we'll switch it off, take it back. It's interesting, it stays there, look. It stays latched on until you put the jumper. Hang on. Now the interesting thing is the jumper's in the 2 to 3 position and it's still stuck at 709. So, I don't know, maybe the switching thing is not working, because that's now stuck at 7.09. No, now we're stuck at, hang on, it's erroring again. Getting a red screen. Yeah, so something, I don't know, there's something wrong here. Maybe I've just dislodged a connection here. Let me just try and press this whole thing down a little bit, just making sure nothing's getting hot. Switch it on. Yeah, it's working again. So I must have just dislodged something. Yeah, sorry, I stopped talking there because the screen went black. And probing around with the scope again. We're still stuck at 7.09 now though. So I don't know, it's not switching clock speeds. This may explain why the other CPU wasn't working. Because if it was stuck at 14 megahertz position without a doubt. Let's try it 1 to 2. Still 7 point whatever, 2 to 3. Still 7.09. So it's not switching frequencies now. If I put that stock CPU in, it doesn't boot again. But the weird thing is, let's say I tried to scope in that clock pin and I can't get it to show the 14 megahertz again. It's just like stuck on the slower speed. Now, I don't know, that doesn't make any sense to me. How did we have it showing the faster speed a minute ago? Have I broke it, changing it over in real time? You're supposed to be able to do that though. Yeah, there's definitely some issue with this because, well, it's reporting 34% speed increase there, showing 709. That's just a boost from having fast RAM. That's all that is. And if I very carefully change that jumper over to the 1 to 2 position, which is actually the slower position, and speed test it, it's going to come back exactly the same. So it doesn't seem to be switching. There, look, 1.34. Doesn't seem to be switching to the higher clock speed. So the really weird thing here, just checking these resistors. One of them is measuring as a short. Yeah. If I put this on continuity test, well, I'll tell you the resistance in a minute. There's one here, it's one of the 10k ones, and if I just measure across its contacts, it shows 000, yeah. Bear in mind this jumper's not here, and I think this is where it goes. So I think it's always on the 8 megahertz speed, or 7 megahertz speed, 0.05 ohms. It's a 10k. Somehow that resistor appears to have died. Now I suspect there's a capacitor on here for a debound circuit, but the capacitors measure alright. So I'm just going to remove this 10k resistor, measure it off there, maybe refit it. It's something to do with that. I mean, that doesn't explain why a stock CPU doesn't blooming work. There's two weird things going on with this. But this is the issue I think I have at the moment, where I'm stuck in 7.09 megahertz mode. Yeah, I'm just going to try and smush it out. What's that little yellow thing there? I don't know, mysterious. You can see it was surface mounted here, so you know what? Maybe that's something to do with it. Well, let's just leave it there a minute, because what I can do now, well, is just measure it again. It's like bodged off, isn't it? Maybe there was some solder underneath joining the two sides of it up. Maybe it was just like a bridge. Well, it's now 10k again. And if we measure from there, now there's a short. Yeah, there is a short. So maybe the I/O pin that goes to on something, I don't know, on the CPLD has died. That's possible. Yeah, I guess this is useful to help you, logically deduce where a fault is. So the fact that that jumper's not working, me tracing connectivity around here led to this pull-up. And they're short, look. I know what's going on. I am an absolute moron here. I should have paid slightly more attention to detail. Let me just point you up. Yeah, and hopefully I've not damaged anything here, but I could have done. Because, well, it was working, then it isn't. Alright, have a stare at that. Let me just get you a bit of focus. Have a stare at that. What do you see? Alright, look at where I removed this. Yeah? Look at the silk screen. Any clues there as to ridiculousness? See this little white line here? A little white line here. White line here. White line here. These components, despite the fact that says R14, what it means is this one here is the resistor, C16, this one here is the cap. Yeah, and I've stuck with the cap where the resistor should be, and vice versa. No wonder it doesn't bleeding work. But you see, now there's this risk I may have damaged an I/O pin or something. That's a possibility, because it's a bit strange in that it was working, then it wasn't. Chances are, if you just fed 5 volts into an I/O pin or something, I don't know. So let's try. Try to think. Easiest way of getting this off. I'm going to try and push this sort of sideways, I think. Right, let's just stick that there a sec, because the resistor needs to go on the top. So if I now try and bring the resistor back, and I've dropped it. Oh god, this is where cav tweezers are really, really handy. I'm going to lose this resistor in a minute, aren't I? I can see it coming. It's going to ping off, never to be seen again. Yeah, and you may be wondering, how did I work that out? It wasn't I just spotted the silk screen. What I noticed is the short, I was looking very, very, very closely at the PCB. See that little trace in the middle there? Yeah, as soon as I saw that, I'm like, hang on a minute, they're intentionally joined. And then, well, the rest is history. Oh, hang on a minute. Is this upside down? I honestly can't tell. No, it's not. Right, so what I need to do here now is, well, just try and smush this into place, I think. It just goes to show, though, that don't go off the orientation of the print. Do actually look for those little white markings in order to give you your clues as to orientation of things on any PCB, really. Right, let's just give that a go. Not sure if I've got any of those CPLDs spare, if we do need to swap it out. I may do, but anyway, let's just hope we don't have to do that. So let's do speed. Come on, please work. Yes! 2.70. And clock speed not reported on this version. Oh, it is 14 megahertz. Yes, thank God for that. Well, yeah, I got there quicker than I would have expected, really. That's the sort of thing that you could spend quite some time messing around with. The temptation might be to swap the CPLD, and that's my first thought. I was like, do I need to reflow around it? But that's really good, isn't it? Almost 3 times the speed of a stock machine. And if you look at the speed, if you look at the speed of a 1200 there, it's 1.17. So it's just good to, you know, well, seemingly, for this benchmark, the 020 on a 1200. So I guess the other thing now, which was the mystery to me as well, is why was a stock CPU not working? Because you think it should do. Word of warning when you're removing CPUs from a board like this is when you leave it like this, there's traces under there. So you've got to just be really gentle and keep moving the screwdriver so you're not putting pressure in the same place each time. You want a blunt movement, really. So like PCB, yeah, it's not marked, but it would be very easy to damage a connection there. I'm just curious to see, will it boot with a stock CPU? Because you know what, this is something that I think should work. Certainly when it's in the slower position, it's in the faster one now. Let's just try it anyway. Yeah, so that is interesting, isn't it? I'll put it in the slower position. Well, it's not that interesting. Now it's in the slower position, it might be interesting. Let's see. That's not 7 megahertz now, 7.09. You'd expect that to work. And it doesn't look. Yeah, so there is something just a bit oddball about this specific CPU. Yeah, I'm getting flash codes here from the keyboard to suggest there's a fault. So, yeah, you do need a faster CPU with this. Well, with mine. Why, though? I don't know. Looking at the photos on GitHub, it's shown with a stock CPU in there, an 8 megahertz one. And you probably can overclock those for the short periods. So, yeah, there's got to be a difference between the CPU I'm using and the CPU that perhaps some others are using. Can't get that in now. Yeah, so this is a HC one. Let's try that again. And we should be able to switch it over in real time now. Right, it's booting again. But you see this one, look at the manufacturer. It's a bit of an oddball. I don't even know what manufacturer that is. Because it begins with a TS, I'm guessing Toshiba. But the symbols look anything like Toshiba. So, I don't know, it's another odd one. There's lots of odd things in this video. So, I'll need to research that, find out what that is, but I'm guessing there's some difference there. There could have been some fault occurred to that CPU previously, like maybe one of its address lines is a bit fluffy or something, or a data bus fluffy. With the stock board and everything's alright, but here it's not. I guess the way to rule that out is to just try one of the other stock CPUs in this position here to see if a Motorola one, for example, works, and that's Motorola, by the way. Yeah, so speed test with the jumper position 1 to 2, which should be the stock speed. It is 33% faster than normal, just because we've got fast RAM, otherwise it'd be 1. And if I remove the jumper carefully, put it in 2 to 3, and in speed test, hopefully that will have reflected. Yeah, there we go, 2.70. So it's working. Yeah, and if you keep your eye there, look, see that flashing? Flashing, just looking at the floppy drive again, which is not connected, then it should flash back here again. Hopefully. There we go, flash, 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 flash. It's booting from the SD card. There we go, it's booted. Haha, fantastic. So I'm curious to see how fast that hard drive performs. My utils, sysinfo. The interesting thing is this card was set up for 1200 as well, and it works on here. So I'll do drives, DH0. So it's using scuzzy.device. So let's see how fast that comes back. Wow, 2.361 meg. That is incredible. For a stock CPU. Yeah, that's actually better than a 1200 gives you as standard. And it's certainly better than an A2091. I can get about 1.2 meg at most really with the A2091. Generally around the 1 meg mark. So that is really good performance on the IDE. And if we do a speed test here, that should just reflect what we saw before when we booted this from floppy. We should show 2.7 times, yeah look, 2.72 times 1.5 megaflops. So I am very pleased, everything's working perfectly there. And there was no need to do anything with the height here. I did put this little piece of ESD bag underneath the solid core ROM, just because there's a few jumpers and things that may interfere with the underneath of that. But this thing here, you know, you can just point it upwards slightly, and it works perfectly. And that was something I read after the event, after I fitted this. It was suggesting putting a shim underneath it before you solder this on, just to raise it up by, I don't know, 0.5 millimetre or 1 millimetre before you solder that IDE connector, just to give yourself a bit more clearance here. But you know what, that's a functional thing, provided it fits in the case here, and I'm sure it would. The keyboard would probably clear this from what I have seen. It's really nice, it's a really nice modification, a really nice upgrade to a stock 500. Or a 500 plus. But once you get the Frontier test, it's always interesting to see how Frontier runs on any upgraded Amiga really. I mean, already I can see that it is twice as smooth there at various points. The part where the ship comes on here and there's a bit rotating on the side of it, you'll notice it goes almost like frame by frame, really slow on a stock 7.09 megahertz 500 or 500 plus. So I'm expecting to see it, you know, twice as fast here really. I haven't got sound connected just now. Yeah, that rotation around the ship is definitely twice as fast as usual. Yeah, and the speed those are rotating there, that's representative of it running at twice the speed it should be. Let me just connect sound up. That's one channel. Second channel. Yeah, very, very pleased. A really good upgrade that. I'm so lucky that I spotted those things on the silk screen when inspecting those jumpers. But you see, that's the first thing when you're working on any kind of upgrade. If you find the jumpers aren't doing what you expect, that's the clue, isn't it? The jumper itself doesn't work, so investigate the jumper. In other words, you know, I looked down at it and I was like, what's nearby? Resistors, surface mount ones in my case, because they were bigger than the actual pad footprint, so I was like, maybe one side's not making a connection. That was when I started measuring across them, you know, is this 10k resistor measuring 10k? Hang on a minute, it's measuring as 0.05 ohms. You know, and that's the thing, so you follow whatever clue you've got. If a specific function is not working, look at that specific function, start with the jumper itself, and then follow it through to its, you know, its conclusion. In other words, if you're looking at RAM, you know, if there was a jumper on there for RAM and that wasn't working, check the jumper out first of all, check its pull-ups, check everything there looks right in terms of layout and components, there's no damage, traces are alright, but then ultimately follow the RAM, look at buffers for the RAM, look at the connections for the RAM, connections on those traces for the RAM to the CPLD, etc. It's all logical stuff. The clues are there. Sometimes it's hard to see the clue, but once you get a clue, just follow the clue. I just want to go back into sysinfo and just see what sysinfo reports in terms of RAM and stuff. I mean, we can see we've got 8 meg there, but like, in fact we can see we've got 1 meg chip, so actually I think there's nothing really much to check in sysinfo. I just want to see what it reports. And see what it reports in terms of auto config as well, actually. If I look at boards here, yeah, there we go, Octagon. So I've got the 8 meg for the Octagon. Now, that's why I'm not sure about that jumper. There's a jumper swap over the ROM. I might just do that. So that's octagon. Let's just power cycle it. I'm changing over the jumper that affects the ROM selection. Look at boards. No, it still says octagon. So, I don't know. Yeah, I would suggest that jumper there switches over between the two 64K blocks. Hang on. I'm quite happy with that, I think. I'm not too fussed about the Octopussy ROM. Although we might get better performance with that. And you may be able to put Live2's LIDE driver on this. 2.34 meg, that's really good. Yeah, it's interesting in that got an ST one there now. Same thing. Like primarily green screens, sometimes a red screen. So you do need to upgrade the CPU, and it's set into the 8 MHz position just now. So that's quite interesting. I'll try another one. I've got another one here. Let's see what this one is. This is a Motorola one. I can't even see a part number on this one. Yeah, this one's a genuine Motorola one. No, green screen again. So that's interesting, isn't it? But I'm using the Beta 2 firmware here, so it's the latest firmware, but nevertheless that doesn't work. Switch it off. You see, it would make sense in the, well, if you were running at the 14 MHz clock domain, but we're not, unless it starts in the fastest thing there, but you know, that's the possibility here, isn't it? Yeah. I've got a 12 MHz one of these that I might try. It's got a pin missing, it's got the clock pin missing actually. I'll just do a bodge for that, but if that works, I'll perhaps leave that on this board. Anyway, that's the 16 MHz one, and it's doing okay now. Yeah, so we tested 3 other standard CPUs there, an ST one, a Motorola one, and then this one, whatever that is. So yeah, 3 different ones don't work, even at the 7.09. Yeah, so I've got a 12 MHz chip here that I want to fit on this and leave it on there. Because, well, 12 to 14, and this is rated 12, it's not much difference, is it? It'll be fine. It's better than potentially wasting a, let's just pull this off, wasting a 16 MHz chip. I'll use some IPA on that in a minute. So you can see I dremeled into the point there previously. Yeah, clock pin broke off. This was due to faffing around trying to get 16 MHz working on the Atari ST. I remember when it happened. It's just like, because I had a wire on there and the pin was bent out, it just got bent one too many times and snapped off right at the neck. So what I'm trying to do is just get that into there. I'm going to solder a pin on like that, and then I'm going to bodge it, you know, put it in the socket and stick this into the hole. So yeah, I need some magnification. I'll report back in a sec. Yeah, there we go. Crazy pin attached. I might just stick a bit of heat shrink up there like that, right up against round that. We'll do that in a minute. Anyway, let's just try that. Right, that's smushed into place. So the final thing here now is to just get that into that hole. That's another reason why some heat shrink around that leg might be a good idea, because well, you can see it's sort of just, it's in there. Yeah, I could flatten the wire down like that. Right, let's give that a try. Yay, that works. So, you know, you would imagine it would. 12 MHz to 40 MHz. It's only a 2 MHz difference. So that's quite a good use of that chip. Anyway, I'll test it out for reliability. I'll play some games on it and stuff. But that is how I'm going to leave it. With a bit of heat shrink around that pin. And I'll just leave this on here. You could heat sink it, but you see, it's not even warm. It's a 12 MHz red part, remember. So I will just use a bit of IPA on that label there. I mean, it's the bodgiest thing ever, isn't it, really? But what else are you going to do? You know, that 12 MHz CPU has been sat around my component tray for, I don't know, 6 or 7, maybe 8 years. Because the 16 MHz mod was one of the first mods I did to my ST, actually. And it runs really well, my ST, at 16 MHz, even with Blitzer. Let's get that into the hole. There we go. So, yeah, a bit of a bodge. That might actually be a problem when the keyboard is in there. I don't know. Anyway, I'm going to test that for a period of time now. I'm testing it here on this game. It's working really well. It's the third round. I'm playing incredibly well. It runs really smooth. This is one of these games where it suggests getting a 1200, and it runs really, really, really well. No slowdown at all. It's just the same as playing on my 4000 or the 1200. I've only been up to this round once so far, and actually, funnily enough, it was on my first playthrough. But you just get, look, so many stuff coming at you, so many bullets from so many directions. Even though I've got that shield at the front, it's incredibly... Oh, look, I don't even know what hit me then. I didn't even see that. And then that's it, I'm knackered now. Absolutely knackered. Because when you look at these things, it's like a bullet sponge. Ugh. It's like, how are you supposed to do that? It's nuts. Yeah, so attempting to play Nightmare here. I'm not sure if this is going to work on this spec machine, because look, why is it doing that? Unless it's decompressing. I don't know, I'll leave it a minute just in case it is decompressing, but stop loading. There's space, nothing. Fire, nothing. Yeah, so we'll just give it a try with the A590. I'm not going to test it with anything else really. Sidecar related, you know, we could test it with the POC 86, we could test it with all sorts of different things. Well, the POC 86 not, because it's a CPU, but you see my point, we could test it with the Matthias Zorro 2 adapter. I think it came from Matthias. But anyway, we'll need to put the RAM in Amnesia, so I'm going to do that, which means don't use the RAM, because we've got 8 meg of Zorro 2 RAM, and that's all you can accommodate with these 24-bit CPUs. Let's switch that on. See what happens there now. Hopefully it will boot from the SCSI. Bear in mind it's got some IDE here that may clash, I don't know, we might need to disable auto boot. Yeah, that's not booting. Let's try disabling auto boot here. Yeah, config in, config out. Do we need to bridge these here? I think we might need a DuPont to go from config in to config out. Let me try that. Well, we'll try it without it. Let's just try it without it, see what happens. Yeah, look, here, there then. So there might be like a pull-up or something like that, I don't know. But now it's booted from SCSI. So when you got that jumper on there, it's just kind of like its own thing in terms of auto config, but then when that jumper is not on there, it's working with this now. So let's just see. We might now find there's no RAM. That might be the next thing. We might need the config in, config out bridge there somehow. This is where if you read this stuff on GitHub, you'd know exactly how it works. I'm just doing lots of guesswork here. Woohoo! Yeah, look, I saw no of the RAM there. I think. Yeah, look. So we haven't got RAM. So we are back to the jumpers here again. Yeah, so the config in pin, it's the 6th one up here. Put a piece of Captain tape, just left a little sliver of about 1mm there, because there's no pads or traces go to the Amiga motherboard, because, well, it didn't use auto config, the 500. But nevertheless, the pin was there. So anyway, I'm just going to put a little bit of solder on that one pin. So 1, 2, 3, 4, 5, 6. This is one here. Right, that's it. And then I've got this single DuPont here with a pin. Doesn't need to be that big. So I'm just going to just trim off, I don't know, about that length there. Make it about half as long. Don't need a very long piece of wire on the end here, so I'm just going to just trim into, there we go, and pull off the end there. Just twist those together as best as I can and tin that. The sleeving may just melt back a little bit, which is what I want. Yeah, flush with that pad and solder it on like that. That's it. Just inspect it to make sure I don't have any bridges there. Yeah, that's going to do the job. Pull back the Captain tape. Just clean around there now with a bit of IPA. So yeah, it's going to be subject to breaking off that when you've got such a small solder point there. Just for good measure, we'll clean that whole edge up as well, actually. and then it wants to be carefully bent around, so I'll do this without putting too much strain there, and put onto the second pin, which is the config in, I think, yeah, it's config in, is going to config in. So now this is kind of aware of the auto config chain there, and it makes sense to me when I was like, why do we have to do this wire? Hang on, it's because the 68k socket here, which is where this is connecting, you know, picking up all its connections, including power and ground, you don't have the auto config going to the 68k slot. Because, well, there's nothing on the board that deals with auto config. It's not like we've got a buster on here, like you do in the 2000. Anyway, let's move all these things out of the way. I'll switch the solder off. And let's give that a try, I think. Switch it on. Now it's erroring again. You can see that there. So, I don't know what's going on here now. Yeah, and actually that's working. It just needed powering off and powering on for a minute, because I had some weird thing with the RAM. Yeah, it was like still in a crashed state. You'll have seen that lots of times yourself with your Guru, and I think the Rev 6 is more prone to that. It's something to do with the reset timing, and this RAM not getting completely, you know, cleared on reset. It's like you can power it off, power it back on, the RAM's still got some contents and you get weird things going on. But anyway, it is booting from the SCSI. Everything seems alright. Woohoo! 2.72. That's it. That is it. Let's test the SCSI performance. Normally you get about 1 meg per second on a stock 68k here, so I'll be interested to see what that comes out like. Yeah, 1 meg per second, so your SCSI sees no improvement in speed whatsoever there. I mean, you can argue performance-wise it's not much different to the Tornado we looked at. There'll be a link top right to that video. So that was where we had some cache for the CPU. Yeah, that's working fine. This SD to SCSI, I talked about the deficiencies in this area here on this, the voltage regulation. It's subject to temperature, and the heater on here, just for after a few minutes it warms up, start to get read errors. And that's all it is. It's this warm ambient air here where the voltage levels start changing. So yeah, you've been warned with those. I think the Zulu SCSI is a far better product, or a blue SCSI. There'll be a video on the blue SCSI coming up. It's like it was giving me a read error on this folder before, saying it's corrupt, and then I know it's not. Just power cycling it and it works. Sweet. Right, so I just gave it one more go with the ultrasonic. It's looking very clean, that now. Yeah, so a quick look at J.Bilander's, I think it's Jorgen, isn't it? I think the way you pronounce it, his GitHub page. Spitfire 500, a low-end 40 MHz accelerator with IDE and 4/8 meg fast RAM. So yeah, there is a jump on there to switch to 4 meg if you've got other devices. Yeah, scrolling down there you can see loads of pictures of the PCB and details about the switches and things. There's lots of useful information on there, things about the different versions of Kickstart compatibility, you know, with your drive sizes and things like that. Also setting max transfer, something you need to do on many of these IDE devices. There's talk there about the ROM towards the bottom, the combined ROM. I think he called it combined because it had been merged with a hack. So yeah, it's not really combined with like a, you know, it's not like I thought it was combined, you know, two different ROMs. It's not. There's stuff there about programming up the CPLDs and things, and basically some good advice on how to best build this. Not the way you've seen me assemble it. You know me, I never follow the instructions. Had I followed these instructions, I probably would have built it a lot easier and quicker. And there's some stuff at the bottom there to do with compatibility with the A590, and the stuff we covered at the back end of this video, really just dealing with the config in, config out stuff, and a little bit of talk about DMA and what have you there. And right at the bottom you've got the bill of materials, all of the components you need to build one of these. Very few components really. Yeah, the most expensive parts there are probably going to be the CPLD and the RAM. And the RAM is about to become obsolete, so if you're building any of these projects, including the terrible fireboards, and you want some Xilinx chips for a PCB you've got, you know, sat on the side, now is the time to go and order some CPLDs. And I would order a few spares, at cost permitting. Yeah, so I do hope you found that video interesting. Massive thanks to sparxUK for sending this to me. I'm sorry it took me so long to build it, Barry. It's been sat around for best part of 2.5, maybe 3 years, this actually. So, you know, these have been available for quite some time. I do need to just clean that off there, there's a little mark. In the next video, yeah, there'll be another part to this series, and that's the 2000 Spitfire. So that came directly from J.Bilander. Massive thanks to J.Bilander for creating this, and for sending me the video, you know, the one you'll see in the next video. It's one for the 2000. Now you may think, oh, it's just the same, but it's for the 2000. It isn't. There are some differences, and the performance is quite a lot better on the one you can get for the 2000. So yeah, anyway, as I said, I do hope you found the video interesting. Thanks to sparxUK. Thanks to J.Bilander. Thanks to Live2 for, you know, officiating the second one, as you'll see in the next video. And yeah, if you did like the video, please give it a thumbs up. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. Every dollar just means we can keep doing videos like this, because I don't always get donations this amazing. You know, I'm having to fund these things myself, and you may say, well, what's the problem with that? And the reality is, as I said before, YouTube provides half of my income. And I have had a lot of people reducing their pledges and stuff. We're just kind of getting to that point where I might not be able to keep doing this forever. So, you know, if you can help, great. It just keeps things going. Anyway, I'll catch you in the next video.